All right, so let's look at this first question. State two cops and a drunk. Well, there are several good statements for this. And let me close the grade book for discrete math so I don't accidentally open that. One of the better ones with a picture is to be found on the notes page. So if you go to the notes page and you go to, and I haven't fixed the dates here for everything yet. But if you go here, this is one of the better statements of it. There are a couple more. There was one in the notes. There's one in the notes that I put online. And they're all equivalent. Okay? But the key things are in this picture here. And this is, for the one from the left. So the key thing, if you remember the pictures, you can reconstruct the statements. And notice also here that I've got a bulleted list. So when I'm trying to memorize something, I memorize the number of bullets, and the how many bullets are in the if, how many bullets are in the end, and then I memorize a picture, and then I reconstruct the thing based on that picture. Now, you didn't have to do the picture. You had to do the statement. But this is how I do it. Okay? So let me show you what I would do. And again, you can find the tactic that works for you. This is the one that works for me when I'm memorizing something. I remember this. Okay? So I remember that it's talking about limits. Oops. I know it's talking about limits. I know that there's some point here, A, and there's some Y value, L. And I could put those on either side. I'll put them right here. And these are actually points in the space. Now, the picture was this. I have this drunk function in the middle. It's doing something like this. But I have these two functions, one on top and one on the bottom, that are kind of controlling it. And I have this concept of near, right? There's some kind of little... So if I'm doing the one-sided version, this is the picture I would draw for myself. And I've got kind of, I've got an F, a top, and a bottom. All right. And this is kind of the picture I draw. And this is the thing I have memorized. I have memorized the picture. And then I kind of have the bullet points memorized, the number of bullets. I think in the notes last time I gave you two conditions and one conclusion. You can do the two conditions and two conclusions thing. And I kind of do, okay, if what has to be true, then what is true. All right. And then what I do is I reconstruct based on my picture. Well, I've got top bigger than bot, left near A. And I actually don't need this whole bit here. I could just say left near A, which means that in the X space, top of X is greater than or equal to. I actually don't need this for all X. I could just say left near A. And then let's see what else I do. Then I look at this thing and I go, okay. So I've got the thing trapped between it, and I know that top and bot are heading to the same place. There's not really enough room for an and, is there? Bot of X to L and top of x to L as x goes to A. So as x goes to A, bot and top both go to L. And I'm doing the left, so I'm going to put a minus there. Then what's true? Well, that means that f of x goes to L as x goes to A left. And this is kind of the minimum that I need, right? So I don't need the picture. The picture's nice. Let me actually put the picture. Can I move the picture? All right. And then I just state where the concepts do, right? So, yeah, if you just wrote what's in their notes, that's fine too. And then what I'm going to say is the top stuff up top, right? So I'm just going to give a little preamble. Let L in the Y space. I could actually just say near the Y space, but in the Y space is fine as well. A in the X space, top, bot, and F, real functions. Something like that. And then when the grader goes to grade it, let me see if there's a way to do this. Let me see if there's a way to show you the rubric without showing a person's thing. I don't actually know how to do this because I don't want to actually show someone's work. Let's see, how do we do that? To be okay. I think I can make this happen without showing someone else's work. So let's see. I don't hit screen 1. I hit screen 2. Okay. So as you can see here off to the side here, can everyone see this? This is what the grader looks like in GradeScope. So you miss points, and the grader, and the reason why I'm going through this is how the tests are graded too. So when you see these statements and things, this is how they get graded on tests. There's a negative kind of rubric here. You start with 6 points. You miss, if you're missing like this and this, these get nagged. And then if you have a nice picture, right? If you have a really nice picture, you'll get 2 points back. And then the stuff in the preamble, you get a point refund. All right. So that's just kind of how the thing works. You get, if you miss stuff, but notice how if you're missing 3 pieces, and notice this if-then structure. If you don't have this if-then structure, if you just have 3 statements, it's 2 points off because you're missing the point. Right? It's an if-then, there's a structure to it. So you can notice that if you're missing everything, you're not going to get anything. But if you notice that there are more than, a theorem is more than the sum of its parts, right? So if you're missing just a part of it, you say, oh, I'm just missing part of it. No, you're actually missing a lot more. Because a theorem is more than just the sum of its lines. It's a full thing that goes together and is used in proofs. Okay. All right. That's kind of how it goes together. You can do there are let me get rid of this so I don't accidentally show somebody's grade. And there are variations on this theme. Now, are there any questions about that? Yes, so if you just wrote what in the notes, that's, the stuff in the notes. That's perfect. You're awesome. Now, note here that there are actually two ways of writing limits, and this is kind of an aside. I can say that the limit as x goes to a of f of x equals L, and there's actually two conclusions here, but, who cares? This is the one that's actually important. The limit as x goes to a of f of x equals L, but I can also say that f of x goes to L. I can write it in this arrow notation. I can also write this. And some people like this better. It's got more of a verb form to it. You pick the one that works for you. There's going to be some things I'm really strict on. This is the absolute equivalent statement. F of x goes to L as x goes to A from the left. And, one of them is more verby, about moving. The other one is more, the limit is. So one of them emphasizes the fact that the limit is an actual number, and the other one emphasizes the fact that there's movement going on. So it's up to you which one you want to use. Which picture in your head works best for you, that is 100% your thing. Yes, so the quizzes come with 2 points, with 2 extra credit points embedded in them. Okay. These limits, these are, people like the coordinator likes to call them popcorn problems, right? They're kind of like one-pointers. These are popular on tests, and they're kind of just the things that you got to be able to come up with off the top of your head. Let's see. So 1 over x. And again, you don't need to do anything, but 1 over x is one of those functions you should just have in your head. Okay? 1 over x looks like this. And this function you should have, if you don't know this function yet, plot it on Desmos, print out its graph, and put it above your bed. Okay? I want you thinking about this function before you go to sleep if you don't know it already. Okay? This function should be in your head, right? At 1, 1, it has -1 and -1 and 1, 1. It goes to infinity as you at this side, negative infinity on this side, 0 at both ends. So as x goes to infinity, y goes to 0. Okay. Let's fill in the other ones that are associated with this. As x goes to 0 from the left, it goes to negative infinity. As x goes to 0 from the right, it goes to positive infinity. So this does not exist. You don't need that explanation. Just writing D&E is fine. And then this is really the same question, right? If n is greater than 1, if this is 1 over x squared, it's going to go like this. If this is 1 over x cubed, it's going to go like that. But either way, as you go to negative infinity, this thing goes to 0. Now, the limit of cosine. Cosine and sine look pretty much like the same functions. They do this. Cosine, as you go right, is 1, goes to 0. Okay. So they both do something like this. This is cosine. But the point is that as you go to infinity, it never settles. Is there a way to turn that off when you click on the screen that the thing comes up? That's really annoying me. Anyway, and this one never settles. Now this one's a little bit harder, right? What happens as I go to pi over 2? What happens to tangent as I go to pi over 2 from the left? So as I go this way, what happens to my tangent line? And the answer is that the length of this tangent line does this. Right? That's the tangent line. And the length of this line gets longer and longer and longer, right? So does everyone remember what the tangent is? Okay, so sine over cosine is the kind of, it's not actually what it is. The tangent is actually this line. Let me see if the trig functions. Wikipedia used to have a really good diagram here about what the tangent was, and it doesn't anymore. Somebody put the stupid one up there. Oh, there it is. So let me show you this diagram. This is off Wikipedia. And I'll post the link here. Oh, shoot. I can't do this because if I do that, I'm going to lose my... Oh, I'll do it again. I'll paste the link here in chat. And I'll show it to you real fast. So this is what tangent is. So as you can see here, if this is the arc length here, the tangent... Oh, they labeled it this one. No, that's not what it is. It's this one right here. So yeah, that one stinks too. I'll draw it for you. So the tangent, if I have a circle, those two lines, by the way, are equal. The length of those two lines are equal. But it's not, oops. What do I want here? Shapes, I want this thing. So if I have a point here on the unit circle, wait, I have to do something other than if I click on, there we go. So if I have an arc on the unit circle, that doesn't show up. So if this is theta, I'll just call that for the arc length, okay? This right here is the radius. The sine is this. I use that color. I need a color I haven't used yet. Here we go. This right here is the cosine. And the tangent is this line right here. That's the line tangent to a circle, okay? At a particular point. And the tangent itself is the length of this, from this point here, from the point on the unit circle to the x-axis. So it's the distance from here to here. All right? That's what it actually is. Now, it happens to equal sine over cosine. That's actually a theorem. But that's what the tangent actually is. So if I think about this, or if I think about these lengths, as I move toward pi over 2 from the left, these are getting longer and longer and longer, and they wind up being negative infinity. I can also do sine over cosine, right? If I do sine over cosine, sine of theta goes to the northiness. What's the northiness here? It goes to 1. Right? As I go up here, as I move this direction, right? This is the direction we're moving. The sine goes to 1. And the cosine goes to 0, but it goes to 0 left. Right? So sine of 1 over sine, I'm sorry, so 1 over 0 left is negative infinity. So either one of those works. The other thing I can do is graph it, and you'll see that it goes to negative infinity. I am talking way too much. I'm sorry. So if I graph tangent of x, you can just see it. It also, as I go to pi over 2, from the left, I go down here to negative infinity. Okay. Oops. There we go. So how do we feel about that 1 to 5? All right. Okay. All right, so let's look at this last one. This graph is a little bit tricky. It's mostly tricky not because the conditions are hard, but because there's not a lot of guidance about where to put stuff. So it's a little intimidating, right? You're just like, well, what am I supposed to do? Well, let's just start. Negative infinity, infinity is a point right here. Negative 2 left, 4. There's negative 2 left, 4. The limit as x goes to 0 of f of x dne. So I'm going to come down here at the bottom. Oops. And I'm just going to write limit d and e. And I'm going to move on with life. The limit as x goes to 1 of f of x equals f of 1. Just going to write a little limit equals function there and move on with life. The limit as x goes to 4 from the left is negative infinity. That I could put on the thing. There's 4 left, negative infinity. I'll have an asymptote. I'll just go ahead and draw the asymptote line, which is not required, but it just tells the grader that I mean to have an asymptote there. F of 4 equals negative 1. Okay, that's easy. And f is defined everywhere. I'm just going to write a note. All right. Yeah. I'm just going through it. I know it's an asymptote. So the question is, how do I know this is an asymptote? The answer is because this is x goes to 4 from the left. I'm going to negative infinity in the y space. And anytime I'm going into negative infinity in the y space, unless I'm going to infinity in the x space, or negative infinity, anytime I'm going to something infinite in the y space, I'm going to have a vertical asymptote of some kind. Okay. All right. So now I'm just going to read from left to right and, kind of create a function that meets these conditions. Okay. So let's just do a little bit of this. It's nice. I don't have a condition saying anything other than that. So I'm just going to fill in the hole. Because, you know, it didn't say that it couldn't be the same value. I need the limit to not exist here. Okay. Here, I need the limit to equal the value of the function. Well, I don't have a condition that told me what that value had to be. I'll pick one. And now I just run my line through it. That makes the limit from the left equal the limit from the right equal the value of the function. Now I need to go down here to negative infinity. Let me do this. We can make it a little bit more neat. There we go. All right. Now I need this point. That's fine. And then there's no other condition, so we'll just do that. Willy-nilly. Now, does my function meet all my conditions? Well, is it the case that the limit as I go to negative infinity is positive infinity? Yes. Is it the case that as I go to negative 2 from the left, I go to 4? Yes. Is it the case that the limit of as x goes to 0 does not exist? Yes. Right? The limit from the left does not equal the limit from the right. Is it the case that the limit as x goes to 1 of f of x equals f of 1? Well, yes. Both are 3. Check. Is it the case that as x goes to 4 from the left, I go to negative infinity? Yes. Is it the case that f of 4 equals negative 1? Yes. Now, did I define an x for everything? Yes. Did I violate my vertical line test anywhere? Nope. Okay. So, all I'm trying to do, so all D said, right? So give me a number. So there's a question. There's someone saying that they don't understand what D means. So give me a number. 3. Okay. So there's no condition in here that said what f of 1 need to be. Three. Picked it. Okay. Now, the condition says because you pick 3 to be f of 1. It's all it says. How do you feel about that? There's not a lot of guidance here, and that was kind of the point, right? I don't have, I don't have a limit as x goes to infinity. I can pick it. I don't have any, the only thing that had to be true was that had to be there. I could have made this go this way, it could have gone this way, or this way, or this way, or done this. The limit didn't even have to exist. Picking 0 is fine. You could have picked 0 as the point. That's fine as the y value. You could have picked 1. You could have picked 6. Who cares? It's your function. So that's the whole point of this. The whole point of this problem is to start, being a little bit more confident with the fact that what you want is what you want as long as it meets the conditions. So anything that met the conditions is fine. For me, I just did something simple. You could have done something wavy. You could have done something like a step function everywhere, except for right there where it had to go to negative infinity. It's totally up to you. One zero, perfectly good point. Okay? Now, -2, 4, this point, you had to have a point. Now, I didn't have to fill it. Okay? I didn't have to fill that. Oops, wrong pen. I didn't have to fill that. This would have also worked. The limit from the left had to be the limit from the right, but I could have picked that as the point. Okay? I just had to define it somewhere. Does that make sense? It could have been defined there. It could have been defined there. I just had to fill in somewhere. Don't care where it was. Okay. I just had to define it somewhere. No, you didn't have to have a hole. It could have just been a line. A was saying that, let me just turn this off. A was just saying that as I went to negative infinity in the x space, I went to infinity in the y space. All right. So how do we feel about this graphing problem, 1 to 5? And if you're still confused about graphing problems, by all means, come talk to me during office hours. The other people that are really good at them are usually the tutors in, I'm sorry, not the Smart Lab, in ASC. Remember, there's that online tutoring stuff that you can go to. But get your graphs working, because the graphs are important. And being okay with the fact that you can do anything you want is also important. It's time to be a little bit more, yay,